everyone. Okay, my name is Abrokwa, and I'm from Ghana. Yes, but I'm currently in Boston waiting for the fall. I'm going to Mount Holyoke this fall. Yeah, hoping to pursue chemistry and computer science. Yeah, so my topic was about porous organic polymers and covalent organic frameworks, and this was selected by my mentor. And what we did was we read research papers put together by other authors, and that was what we used as case studies. Yes, so that's what we're going to talk about. Yeah, so the research topic was mainly about it's from organic chemistry because that's what my mentor Christina Kong is well versed in. She's a PhD student at Princeton. Yes, that's part of her topics. She's dealing with polymers. So the topic, the research topic was about the synthesis and applications of selected number of porous organic polymers and covalent organic frameworks, the methods used to prepare the polymeric materials, experiments performed to demonstrate their properties and structural features, and some limitations of the material, as well as future opportunities for improvement. And we read from 5 research papers. Okay, so the first material was porous organic polymers, and I'm going to explain that. So porous organic polymers are covalently linked porous and amorphous materials with a backbone. They are composed of mainly carbon. They have excellent thermal and physiochemical stabilities, extensive surface areas, and tunability. So an example is what's shown here. So it's just a chemical compound made up of carbon, mainly carbon or other chemical compounds. So this is just an example of a POP for short. Yeah, so over here you can see bonds, a lot of bonds coming together. So I won't go much into detail, just an example. So the next one. Okay, so the next material or compound we talked about was COFs, or covalent organic frameworks. So covalent organic frameworks are 2 or 3 dimensional porous crystalline structures made up of organic building blocks. They have repeating and uniform unit cells, as well as high surface areas, intrinsic multidimensionality, organized cell structure, and porosity. So these are also examples of covalent organic frameworks. So the difference between the covalent organic frameworks and the porous organic polymers are that COFs are 2-dimensional or 3-dimensional. 2-dimensional mostly because they are flat, yes, and they don't have they're like crystalline, meaning building blocks. Yeah, they're like diamond. Yes, so diamond has a distinct feature. Like you can see that it's round because of the building blocks. That is how COFs are. But POPs are they don't really have a shape. If you remember what we did in biology, I think we did amoeba. Yeah, amoeba has an amorphous shape. It doesn't take any distinct shape. It can take any shape. That's how POPs are like. So that's the main difference between POPs and COFs. So the next one. Okay, so the main part of COFs and POPs we've studied from the research papers and the uses were POPs for selective carbon dioxide adsorption. So POPs and COFs have a lot of functions and applications in the environment, but we focus mainly on these from the research papers we studied. So the first one was POPs for selective carbon dioxide adsorption. Right now we have global warming and all, and everybody's trying to work on ways to reduce that. And that is one way POPs can help with that. So POPs for selective CO2 adsorption, redox active hexatrinaphthalene, and POPs for energy storage in lithium ion batteries. So apart from atmospheric uses, can be used for energy storage, can be used as a redox active material. It can also be used, and COFs can also be used for CO2 capture. And with that, you'd have to use carboxylic acid. So the research also talked about how carboxylic acid is added to COFs and how that helps in CO2 capture. And the most interesting part, what I found most interesting, was a fluorescent COF for the detection and removal of mercury in water. So as mentioned in the first slide, COFs have tunability. They can be maneuvered or um, manipulated to use. And an example is how it has a fluorescent nature. So you just use a fluorescence that the COF has, and it helps in the detection and removal of mercury in water, which also helps in the environment, removal of bad materials in water bodies and all. Yes, so the next one, please. Yeah, so as part of the research, we also studied methods of manufacturing these materials. An example was metal catalyst coupling, the Sonagashira cross coupling, and the ring opening reaction. So this is an example of the Sonagashira coupling. So an amine group is added to hydrogen, and yeah, so it's over here. I won't go much into details. Yeah, the next one, please. Okay, so as I said in the previous slides, POPs and POFs are used in gas capture and separation, energy storage, detection and removal of mercury from water. Please, the next one. Yes, and about working with my mentor who's a PhD student, was very patient and understanding, because the time that I was in Ghana, we had different time zones, and she was still in the lab doing her research, and I was doing something else. So it was difficult to find meeting times, and sometimes she had to postpone and reschedule, but she had patience. And coming from an African background, we didn't really study much about organic chemistry, but she had time for me, and she gave me the research papers that I needed to do the research. And yeah, now I have more knowledge in organic chemistry than I did before. Yeah, and yeah, so that's all. I want to thank Talaria. I want to thank my mentor. Thank you for this opportunity. And I can say I'm ready for college now. Thank you so much.